Good evening and welcome once again to my YouTube channel, Pearson Excel International Maths by Mr. Kamoto. And we will be explaining example 3 of chapter 1, Pure Mathematics 4. And you're on page 3 and we're saying, in this one, prove by contradiction that the root of 2 is an irrational number. The root of 2 is an irrational number. And before we can go to solving this question, we must remind ourselves two key points. That a rational number is that which can be expressed as a over b, where a and b are integers. A and b are integers. That is a rational number. Let me say something else also. And the second point is an irrational. An irrational number cannot be expressed in the form a over b, again where a and b are integers. It cannot be expressed. So with that in mind, we have to have our assumption. What are we assuming? Assumption. So we are supposed to prove by contradiction that root 2 is an irrational number. So our assumption is that root 2 is a rational number. We have contradicted what we are supposed to prove is a rational number, meaning that, and if it is a rational number, therefore, then root 2 can be expressed as a over b for some integers a and b. And assume that this fraction where a and b cannot be simplified, they cannot be simplified further. Where a and b cannot be simplified further, it means that fraction has its final stage in the form of a over b. What does that mean? They have no common factors. They have no common factors. And as such, if root b is a over b, we can square both sides and have, squaring both sides to have a is equals to, or rather 2, to have 2 because root 2 squared is equals to a squared over b squared. What does this mean? This means cross multiplying both sides, a squared is equals to 2b squared. What does this mean? Because a squared is 2 times b squared, Any number multiplied by 2 is even number. So a squared is even, and so is a. Because in our last video we have concluded that if a is even, a squared is also even. If a is even, then it can be expressed in terms of a, and so is a is even. That means we can express a in terms of what? Then a can be expressed as a is equals to 2n, whatever the value of n is, because a is even. Even number is anything that can be divided by 2. And if a is equals to n, then a itself is even number, where n is an integer. And because a squared by itself is 2b squared, then it follows that a squared, then it follows that when we talk about a squared, it's 2a. A squared is 2b squared. So we are saying because a is 2n, 2n squared is also equals to 2b squared, because a is 2n and a squared is 2b squared. So a squared can also be 2b squared, which means 4 n squared is equals to 2b squared, or 2n squared is equals to b squared. That is exactly what it means. That means what? B squared is also even. That meaning b squared is also even, and so is b. So if b squared is even, so b is also even number. So if a and b are both even, so if a and b are both even numbers, then what? A over b can be simplified further, because they must be having a common factor too. Can be simplified further because they have a common factor, at least common factor 2, because they are both even. Even numbers can be divided by 2, so they both have a common factor. And this contradicts assumption, and our assumption is a rational number, then root 2 is a over b, where a and b cannot be simplified further, have no common factors. That already is contradicted here, because we have found out a and b numbers, and as such can be simplified further due to the fact that they have one factor. So we are simply saying this contradicts the statement that A and B have no common factors. And our conclusion is root 2 is not rational. We have contradicted the that we made about a rational number. Therefore, root 2 is irrational, an irrational number. Having contradicted our assumption, then root is an irrational number. Follow through and make sure you understand proof by contradiction, and that is exactly what we need to show in this particular chapter. All right?